Docker architecture explained. Docker consists of multiple components working together. These components manage images, containers, networking, and storage. Understanding Docker architecture helps explain how Docker works. This knowledge becomes valuable when troubleshooting Docker environments. Why learn Docker architecture? Docker commands appear simple from the user's perspective. Several components work together behind the scenes. Understanding the architecture improves troubleshooting skills. It also makes advanced Docker concepts easier to learn. Main components of Docker: Docker client, Docker engine, Docker daemon, Docker images, Docker containers, Docker registry. High-level Docker workflow. User enters a Docker command. Docker client receives the command. Docker engine processes the request. Docker daemon performs the required actions. Containers are created and managed automatically. What is Docker client? Docker client is the interface used by developers. Commands such as docker run and docker ps use the client. The client sends requests to Docker engine. Users interact with Docker through this component. Common Docker client commands: docker run, docker ps, docker stop, docker images, docker pull. What is Docker engine? Docker engine is the core software platform. It manages Docker resources and operations. It coordinates containers, images, networks, and volumes. Docker engine acts as the heart of Docker. Responsibilities of Docker engine: container management, image management, network management, storage management, resource coordination. What is Docker daemon? Docker daemon is a background service. It continuously listens for Docker requests. It performs the actual Docker operations. Most Docker tasks are executed by the daemon. Tasks performed by Docker daemon: creating containers, starting containers, stopping containers, downloading images, managing Docker resources. What is a Docker image? A Docker image is a read-only template. Images contain everything needed to run an application. Images are used to create containers. Multiple containers can be created from a single image. Contents of a Docker image: application code, runtime environment, libraries, dependencies, configuration settings. Image versus container. Image equals blueprint. Container equals running instance. One image can create many containers. Containers are created from images. What is a Docker container? A container is a running instance of an image. Containers execute applications in isolated environments. Containers are lightweight and portable. Containers share the host operating system kernel. Benefits of containers: fast startup times, resource efficiency, portability, consistency, scalability. What is a Docker registry? A registry stores Docker images. Images can be uploaded and downloaded. Registries simplify software distribution. Docker Hub is the most popular registry. Understanding Docker Hub. Docker Hub is the default public registry. It contains thousands of ready-to-use images. Developers can share and download images. Public and private repositories are supported. Popular Docker Hub images: Jinx, Ubuntu, MySQL, Redis, Postgres. What happens during Docker run? Docker receives the command. Docker checks for the image locally. Missing images are downloaded automatically. A container is created and started. Step 1. Check local images. Docker first searches local storage. It checks whether the required image exists. Existing images are reused. This improves performance and speed. Step 2. Download image. If the image is missing, Docker contacts Docker Hub. The image is downloaded automatically. The image is stored locally. Future runs can reuse the image. Step 3. Create container. Docker creates a container from the image. Container settings are initialized. Required resources are allocated. The container is prepared for execution. Step 4. Start application. Docker starts the container process. The application begins running. Services become available to users. Docker continues monitoring the container. Docker request flow. User. Docker client. Docker engine. Docker daemon. Docker image. Docker container. Docker local resources. Images. Containers. Networks. Volumes. Configuration data. Real-world example. A developer runs Docker run Jinx. Docker checks for the Jinx image. Docker downloads the image if necessary. A web server container starts automatically. Why Docker architecture matters. Simplifies application deployment. Automates environment setup. Improves consistency. Supports scalability and portability. Enables efficient container management. Key takeaways. Docker client receives user commands. Docker engine manages Docker operations. Docker daemon performs the actual work. Images act as templates for containers. Registries store and distribute images. Lesson summary. Docker architecture consists of multiple components. Images and containers work together. Docker Hub stores container images. Docker automates application deployment. Understanding architecture helps build Docker expertise.